So to overcome this problem, basically we use a symmetric way. This is called it as a symmetric way, symmetric cryptography algorithms, where you are maintaining secrets in at multiple places. So this is where this to resolve this problem we have an RSA algorithm, and it is an asymmetric cryptographic algorithm. And asymmetric actually means that itself it's work on a two different keys, one with the public key and the private key. As the name described, that the public key is given to everyone and the private key will be kept as a private. Okay. Okay, enough statement. Let's discuss this in a detailed way. Okay. So what we can do here is, so what we can do here is we will remove all this secrets from the server. First of all, we'll remove all the secrets from the server. Okay, just see it like how we are resolving this problem. Okay, we'll remove the secrets from the auth service also, and we will be using now as a RSA 256 algorithm. RSA 256 algorithm on the JWT token also. On the header part you should have to pass it like, okay, from now the signature will happen with RSA 256. So as I had already told you, if you are using RSA 256 algorithm, there will be need of two keys. One is private key and one is public key. Private key, basically we use it to digitally sign the signature, and public key, basically we will be using it to verify the signature, right? So so signing the signature, where it is happening, it is happening on the auth service, so we will keep the private key here. Okay, and all of the other server will hold the public key. There is as I already told you, there is no secrets, very much secret sensitive information available on the public key. If it is compromised also and private key is safe, that doesn't much matter it. You just have to predically know about it, that the public key is compromised. You can replace it with another. But this is not very highly sensitive information, which we call it as a public key, which will be kept it into all of the servers. So what I told is, like, we will keep the private key into our auth service. Related with this private key, this public key, right? This public key you can store it into the multiple server. Or what you can do is, if in case you want to resolve it, if you are still saying it like this public key is a problem, what you can do is, like, you can keep this public key also into this auth service. And each time when the request comes to your auth service, when the JWT you are signing, you will sign that JWT with the private key. Okay, and send it to the client. If request go to another server, any of the server, this server will actually make request to our auth service to get the public key. Okay, so to get the public key, it will this they will get the public key, and with the use of that public key, basically the server will validate that signature is valid or not. If it is valid, it will allow them to take the resources. Hope it makes sense and clear to you. So suppose that I'm just taking an example. This request, they are going to this server. This server will take the headers and then the your payload, and this server required a public key. So they will ask the auth service, they provide me the public key. This S2 will get the public key, and then S2 will verify that signature. With this one, you're resolving actually two problem. First problem is, like, you should not have to maintain your secrets in each of the server first. And second thing, at the time when you want to rotate your because this is also important concept, and you should have to keep rotating your secrets and your public and private key, which we'll be speaking about on the best practices. So to make it more secure and see it like any your logs, to see it like any wrong thing is happening, right? So this is how the public and private key works. I've observed, so in some of our solution, like, I've also worked in few of the solution, that there is another way also. What is that another way? I will just try to, and this is a bonus. So suppose that this is a one SaaS service. Okay, there is one SaaS service. With this SaaS service is provide some of the service to you, and this service you actually want to consume it, okay, into your into and this is the client. Okay, and this is also an application, web application. This client want to consume it. So this client, what they will do is, they will also utilize the RSA algorithm to asymmetric way, basically, to sign the JWT. So what way they're doing it, like, this client will generate the RSA public and private key, and then the private key, this client will be holding it. Okay, this client will hold the private key. Okay, and this service, the SaaS service, will hold the public key. Okay, this also resolve a very good problem. If you can see it, like, once this client is going to the SaaS service, what SaaS service this saying is, like, you prepare your JWT, sign it with your private key, and come it to me. Okay, so once they represent, and there, here it is, no, it is actually providing the authenticity. Okay, they are providing their authentication with their, because this client is registered with the SaaS service, they have provided some of the client ID, client secret, so integration key, and some more information into it. And then what they do is what they do is basically, they prepare the JWT, they pass all the claims, what it is required, like client ID, client secret, and all those information into the JWT, into the claim, into the payload, and they sign that JWT with this private key. Okay, they send this request to the SaaS service. SaaS service will basically looks into the header, the payload, and then this, with this public key, they will sign it, compare it. If it is matching, then well and good, you can utilize. They will prepare one access token. Okay, they prepare one access token, and then they send it to the client. What they do is, like, whenever they make call to any of their APIs, they attach this access token into it, and this access token will help them to get their resources. Okay, coming to our part, like, what are some of the best practices you can use it to make more safer is, what you can do is, like, suppose that when the server validates and prepare the JWT, right, ask them to, means, provide a claim that, in a way that it expires in a very minimal time. Okay, in a very minimal time, like, either in a 1 day, or it should not be like a 1 year of 1 year of access token you want to use it. Okay, the JWT, it will be expiring after 1 year. That is not more much secure, because in case, if it is compromised, they will be continue using it for 1 year. Okay, that's the best practice. Make it as a minimal, whatever is, what is your, best is for 15 minute. Okay, that access token. In some of the cases, I have seen it, like, each time when they go it, and to the server, they will prepare their JWT, and then they will prove their identity, and then they will ask them to generate a fresh JWT. Okay, for each and every request. Okay. Other best practices is, whenever you are communicating from a client to a server, use always as a HTTPS. Okay, don't go with the HTTP. It actually make your communication more secure, because JWT JWT, basically, you should have to, because anyway you are sharing some of the client information, right? So it should be passed with the HTTPS. Right. So these are two things I just want to discuss on the best practice. There are multiple, but we can explore more, and I will highly recommend to go with the JWT.io and have a look into it. It has a great detail. So it's a long video, but hope you have enjoyed, and I tried to cover all of the topics, whatever I can cover into it. Thank you so much for your patience. Thank you so much. Take care. Bye bye.